So electronegativity is a definition in chemistry that defines how strong an element pulls or is attracted to electrons. So this is a word you'll definitely need to be familiar with. I'll put a star by this. Electronegativity is a definition or a term that means how strong an atom or element is attracted to electrons. And it increases as you go up and right on the periodic table. So this is kind of like a review from chapter 2, where we looked at the periodic table and the relationships of all the elements on the periodic table. If you go up and right, the electronegativity increases. So I'm skipping through that because these values are on your periodic table. Values are relative and not everybody agrees on the exact number. So we've kind of condensed this into your periodic table. So let me show you this. I stopped my screen sharing for 1 second. I'm just going to open my periodic table. If I can find it, there we go. Give me 1 second. I'll just share your table with you. All right. So your electronegativity numbers are here. And they're given to you on the periodic table. I'm just circling some of them for an example. These numbers are given to you. They go from 0 to 4, 4.0 or 0 to 4. And you'll notice, let me clear my drawings and let me zoom out a little bit. You'll notice that electronegativities go from 0.7 or less than 0 up to, and I'm over on the right side of the screen now, up to 4. 4 would be our largest number of electronegativity. So if you look at this table, periodic table, the highest number of electronegativity is fluorine with 4. That means fluorine, out of all of the elements on the periodic table, fluorine is the most attracted to electrons. Now, another thing I can mention is if you look at your noble, I don't know if it's, hold on, there we go, noble gases. There are no electronegativity numbers there. And that's because they are not really attracted to any electrons. They have a full octet. If we drew the Lewis dot diagrams, they would not be attracted to any electrons. So you'll notice the noble gases do not have an electronegativity number. So again, electronegativity is here. And you'll notice the noble gases do not have them. Again, this is because of the definition of noble gas, or sorry, the definition of electronegativity. So let me share my new screen here. Yeah, so the values of electronegativity, again, the attraction of an element towards electrons are given as a number between 0 and 4. F, or fluorine, is the most electronegative. Up here, we ignore the noble gases, and francium, down in the bottom left, is the least electronegative. So this, like what, what's the purpose of this? Most elements do not, most bonds between elements do not have equal electronegativity. They don't always share electrons the same. So if one element is much stronger, now, okay, so much stronger, I mean more electronegative. I'm just going to say electroneg, but I mean electronegative. We would call this a polar bond. So you can see in the image down in the bottom of the screen here, or bottom of your PowerPoint, a polar bond and a nonpolar bond. There's different types of force at play. So you can see here, we have a chlorine and a hydrogen, and the chlorine is pulling a lot stronger than the hydrogen. However, over on the right side, you can see the two hydrogens are sharing it equally. So this changes our bonding, or changes how things bond. So when two atoms have a large difference in electronegativity, sorry about that line, one atom is stronger and pulls the electrons closer to it. We would call this a polar bond. And we could figure this out by subtracting the electronegativities. So these are numbers from the periodic table. So if you're wondering where these numbers come from, like 2.2 and 3.2, they come straight from the periodic table. And if I calculate the difference in electronegativities, if I subtract the difference here, I notice chlorine is 3.2, hydrogen is 2.2, so that's a difference of 1. We would call this a polar bond. A polar bond is when the difference in electronegativities between the bonds is more than 4, or I should say 0.4. So chlorine almost gained an electron here. It's not ionic. Oops, let me fix that. So this is not an ionic bond. It is not actually gaining an electron, but it almost did, which means it has a partial negative charge. Hydrogen lost an electron, which means it has a positive, or a partial positive charge. So this is where we get a molecule that would be called polar. So when two atoms have the same or almost the same electronegativity, the electrons are shared equally. Oops, my pen. This is called nonpolar. A nonpolar bond is when the difference in electronegativities, oh my gosh, my pen is killing me here today, is when the difference in electronegativities is between 0 and 0.4. So if the difference between the molecules are 0, or 0.1, 0.2, we would call this nonpolar. If it's bigger than 0.4, we would call this a polar bond. And this image here on the bottom of the screen, you have to remember. The idea is, if you are between 0 and 0.4, you would have a nonpolar bond. It's not polar, meaning it doesn't have an extra charge. It doesn't have an extra attraction to electrons. If you have your bond, or the difference in electronegativities between 0.4 and 2, This would be called a polar bond, meaning it does have a difference in electrons, or we would say the electrons are shared unequally. And if the difference in electronegativity is bigger than 2, we would just simply call it ionic. So think about your periodic table and think about your electrons. If two non-metals get together, the difference in electronegativity there can be between 0.2 or 0.1 and 2. If you're looking at a non-metal and a metal, the difference in electronegativity can be much greater, so it can be bigger than 2, and this is what we would call ionic. So the last thing I want to do today, and then we'll finish for today, is this question: are these bonds polar? Well, let's look. So we have silicon and iodide and chlorine and bromine. So let's look at our periodic table. I'll open this up for you so you can see. Just give me a second. Okay, so we're looking at, for the first bond, is silicon and iodine or iodide or whatever you want to call it. We have 2.7 and 2.6. Okay, so that doesn't look like a big difference to me. So 2.7 and 2.6. So I'm going to go back and share my other slide. Oops. So our difference, this means difference. So our difference in electronegativity is 2.7 minus 2.6. It's 0.1. Very, very small, very small. So if I go back here to this slide, that means this compound between 0 and 0.4 would be a pure covalent bond. And I'll pick another color here to write that. Sorry. Whoa, sorry guys. All right, well, let's look at Cl and B. And again, I'll share a different slide here. Just give me a second. So we're looking at chlorine and bromine. Cl and B. Let me clear this. Oh, I don't know why I can't clear this. All right, I can't clear my drawings, but that's all right. So Cl and B, we're looking at 3.2 and 2.0. So let's go back to my slides. Sorry, give me 1 second here. So this would be 3.2. And this is 2.0. So my difference in electronegativity would be 3.2 minus 2.0, so 1.2. And if you go back to my notes here, just clean this up. You'll notice that if it's between 0.4 and 2.0, we would call this a polar covalent bond. All right. So that's basically it for me today. Your marks, your test marks are on D2L. They're not on your SharePoint or the college website yet, but they are on D2L. If you guys have any questions, let me know. Other than that, I am done for today. So yeah, if you have any questions, let me know in the chat. Other than that, have a great, fantastic, and safe day.